Hello, my lovely physical science classes. So we're going to be looking at section 3, particles in solution. So after doing your particular lab, you realize that different amounts of solute can dissolve in different amounts of temperature. Well, in this case, we're going to look at how particles dissolve in solution and what they might do to that solution, sort of the properties of it. So things that we're going to look at is we want to determine sometimes solutions can conduct electricity, so we'll be looking at that. We'll also describe how antifreeze works, because antifreeze you put in your car, or you will when you start driving. Very, very important stuff. So we want to make sure that we kind of know how those solutions actually work. So first thing that happens in most solutions is we're going to make particles that have a charge. So in this case, everything in your body requires charged particles to work. So think of, waving your hand to your friend, or, sending a message down your arm to write. Anything at all that involves using your nerves needs electricity. So how do we get electricity in your body? I mean, it seems kind of weird that, electricity in my body. Doesn't electricity normally kill me? So we gotta have a safe way to actually conduct the electricity through your body. The way that we do that is through the ions. So hopefully this is not a new term. Ion is definitely a term we've used before, and we use it just to mean a charged particle. So a really, really good thing that a lot of people like to drink is they drink Gatorade. So whenever your body is sweating a lot, working out a lot, your body is essentially losing these ions. So to help your body to replenish itself, to provide ions back into your body, a lot of times athletes, even people being outside for long periods of time, will get dehydrated. We need those electrolytes in your body to actually get all of your nerve impulses to be sent whenever your brain thinks of them to be sent. So first it helps conduct electrical impulses in your body. The strongest type of electrolyte is salt, so that's sodium chloride. If you ever look at the back of a Gatorade bottle, the number one thing in there is going to be sodium and it's going to be chloride. Those are the two biggest molecules that you need in your body to conduct electricity. Which is why also, if you ever, see on TV where people get electrocuted while standing in water, most of the time it's not the water part that's doing the electrocuting, it's because there's ions in that solution that allows the electricity to be conducted through the water via these ions and of course to the person. So if somehow you could get absolutely 100% pure water, it's not going to do anything if you put electricity in it. Don't try that at home. We also have substances that do not form ions at all. So if they do not form ions at all, they do not conduct electricity at all, we are going to call these non-electrolytes. So non-electrolytes are things like sugar. Sugar does not break down into ions. Also, some kinds of alcohols, ethyl alcohol to be specific, organic molecules, they don't break down to form ions. If we want ions to form, we're going to try and do it in two different ways. These two ways are very, very similar to each other. Both of them involve breaking down a compound. The only difference is when we have ionization, our key word here, neutral compounds. So we have a neutral compound that's broken down into its ions. So essentially what we're doing is we are making particles that have charges. So we're a process in which particles obtain a charge. So before, when they're bound together with their compound, they're neutral. When we ionization and break them apart, we're going to give them their charge back. So just an example, HCl, so hydrochloric acid, when we break it apart, gets broken down back into its components of H plus and Cl minus. So over here at the compound, it's neutral. There was no charge associated with it. But as soon as we break it down, now we're giving it its charge again. So that's our only difference between ionization, it's neutral, and our next word, dissociation. Very, very similar, I know. So this case, and I underlined them, when ionic compounds are separated into ions. So these compounds are ionic. Remember, ionic would mean a metal with a nonmetal, or if you remember doing the numbers, those would be bonds greater than the 1.67. So these particular ones, they are already charged particles. So an ionic compound, both of the ions already have charges. In this case, when we separate them, all we're doing is still just separating already charged particles. Usually we're going to break these apart when we add them to water. And the most common one, the one you've seen in class, is salt. So sodium chloride is an ion. So we have the metal with a nonmetal, that makes it ionic. So we already have a positive Na, even though it's over here joined together. Ionic means it still has a charge. So all we're doing is breaking apart our positive sodium and our negative chlorine. All right, almost done. Effects of solute particles. So sometimes when we add particles to solutions, we're going to actually affect its physical properties. So physical properties, if we just remember, are things that can be changed that aren't chemical changes. So we could change and make it a different color. We could just change the boiling point, the freezing point. But if we start changing more than that, that's a chemical property. So think about freezing points, boiling points as a physical thing. So you've all probably, in the wintertime, seen the salt trucks on the road. Salt trucks are essentially trying to keep the roads from freezing. So they add salt to the roads to try and lower the freezing point. So that's our first thing to talk about, lowering our freezing points. So that's one really good example. Another one is your car. Antifreeze. If you've ever had to add it, you may or may not have yet, but you'll definitely get familiar with it within the next year when you start driving. So antifreeze is something that every car has to have. What it does is it's going to keep your car from freezing in the wintertime. Now around here, around the Illinois area, the Midwest, it doesn't get bitterly cold as it does maybe up in the upper peninsula of Michigan or even farther up into Canada where antifreeze is hugely needed. We still need it here though, because in this case it still needs to keep our cars from freezing as well. So depending upon how much you add depends on how much it lowers the freezing point. So if I add more antifreeze, I get a lower temperature. If I add less antifreeze, I get a less temperature. So the cool thing is there's also animals that have natural antifreeze in their body. Caribou live way up in the polar regions. They actually have in like their lower legs, because they're in the snow and the ice all the time, that, they don't want their hooves and their calves to freeze. So they have a natural antifreeze that just happens to occur in their lower legs because they're going to be standing in ice and snow for very, very long periods of time. It's very similar to the fish. The fish that live in the polar regions also have this same natural antifreeze that allows their bodies not to freeze. And also, some insects even have a natural antifreeze. So the example that we started with, adding salt to the roads in the wintertime, This is just another mechanism to help lower our freezing point. So if we can lower the point at which water freezes, we can keep it from freezing, making our road conditions a whole lot better to drive on. The other thing that solutes can do when added is it can help to raise the boiling point. So you're probably wondering, well, why is it good to raise the boiling point? Sometimes we want things to not overheat. So again, this comes down to your cars again. And I know it sounds odd, antifreeze keeps it from boiling over, but antifreeze works in both ways. It's a very, very good chemical. So surprisingly enough, it also will raise your boiling point depending upon the amount of solute that you add. So if you add more antifreeze to your car in the summertime, you're going to help the car to stay cooler because we're going to raise the point at which it actually boils. And that will be it for you guys. So just make sure you answer or finish taking notes on this. We'll answer some questions tomorrow in class, and hope you guys had a good evening. See you later. Bye-bye.